December 18, 1944, 12:47 hours, eastern ridge of Mount Tapochau, Saipan. The afternoon heat pressed down like a living weight when Captain Hiroshi Yamamoto of the 43rd Independent Mixed Brigade crouched behind volcanic rock formations that had sheltered his men for 3 weeks. Through the sweltering Pacific air, the American mortars had maintained their relentless rhythm since dawn, each round whistling overhead before exploding harmlessly in the jungle canopy behind their positions. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The predictable cadence had become almost comforting to veterans who had survived Guadalcanal and witnessed the systematic destruction of Japanese strongholds across the Central Pacific. These soldiers understood American tactics: high explosive rounds softening targets before infantry assault, white phosphorus for marking positions or creating smoke screens. The Americans followed patterns, and patterns could be anticipated, endured, survived. Captain Yamamoto adjusted his field glasses and observed the Marine positions across the ravine. 3 months of island warfare had taught him to read the signs. The sudden cessation of individual harassing fire, the barely visible movement of forward observers repositioning, the methodical adjustment of mortar base plates that his trained eye could detect even at 800 meters distance. Something had changed in the American preparations, but 30-year veteran of the Imperial Japanese Army could not yet comprehend what. At precisely 12:48 hours, the whistling stopped. Not the gradual reduction that preceded previous assaults, not the temporary lull that allowed for ammunition resupply. Complete silence stretched across the contested ridge, broken only by the distant sound of surf against coral beaches and the mechanical drone of American transport aircraft maintaining their endless supply runs to newly constructed airfields. The silence felt different, more deliberate, more ominous than the bombardments that had preceded it. Japanese soldiers who had learned to time their movements between explosions found themselves frozen by the absence of sound. Veterans of bonsai charges who had rushed American positions under covering fire now pressed themselves deeper into defensive positions carved from living rock. What happened next would fundamentally alter Japanese understanding of American tactical innovation and introduce Imperial forces to a weapon system that combined chemical warfare with precision delivery in ways no military doctrine had anticipated. The Marines of the 4th Regiment had developed something beyond conventional mortar tactics, something that would transform defensive warfare and challenge every assumption Japanese commanders held about American military capabilities. American approach had followed established patterns observed across the Pacific Campaign. Naval bombardment to suppress coastal defenses, followed by amphibious assault to secure beachheads, then systematic reduction of inland positions through combined arms tactics. Artillery and mortar fire prepared objectives. Infantry advanced under covering fire. Engineers reduced obstacles, and the cycle repeated until organized resistance collapsed. Japanese defensive doctrine, refined through bitter experience at Tarawa, Saipan, and Tinian, emphasized depth over width. Instead of attempting to defend beaches, Japanese forces would allow American landings while maintaining positions in terrain that favored defenders. Cave systems provided protection from naval gunfire and aerial bombardment, while offering multiple firing positions that could bring converging fire on American advance routes. The system had proven remarkably effective against conventional American tactics. High explosive shells might collapse cave entrances temporarily, but Japanese engineers had developed techniques for rapid tunnel clearance. Flamethrowers could clear individual caves, but could not reach the deep galleries where Japanese forces maintained their command posts and supply dumps. Even direct assault by infantry required Americans to approach across open ground under fire from multiple concealed positions. Captain Yamamoto had witnessed American frustration during previous assaults. Marine companies advancing across the ravine would encounter fire from positions they believed had been neutralized, forcing retreat and renewed preparation fires. The cycle consumed American ammunition while inflicting steady casualties on attacking forces. Japanese defensive tactics, though ultimately doomed by American material superiority, could extract maximum cost for every meter of ground conceded. The 4th Marine Regiment had established their forward positions in a semicircle roughly 600 meters from the main Japanese defensive line. Their mortar sections, equipped with standard 60mm and 81mm weapons, had maintained a regular harassing fire for weeks. Individual rounds targeted suspected observation posts, supply routes, and cave entrances. The fire pattern had become so routine that Japanese soldiers could predict timing and take appropriate cover. Staff Sergeant Robert Mackenzie commanded the 1st Battalion Mortar Section, 24 Marines operating 8 81mm mortars, positioned in carefully camouflaged emplacements behind the forward rifle companies. Mackenzie had served in the Pacific since Guadalcanal, participating in the development of close support tactics that transformed American infantry operations across the island campaigns. The Marines had recognized early in the Pacific War that conventional artillery proved insufficient for reducing fortified positions in jungle terrain. Artillery shells designed for European warfare, where targets typically occupied open ground or light fortifications, could not penetrate the deep cave systems that Japanese engineers constructed in volcanic rock formations. Naval gunfire, while devastating against surface targets, could not reach positions protected by meters of solid stone. Mortars offered tactical flexibility that heavier weapons could not provide. The high trajectory allowed shells to reach positions protected from direct fire, while the relatively light weight enabled forward deployment with infantry units. More importantly, mortars could deliver specialized ammunition types designed for specific tactical situations, including illumination rounds for night operations, smoke rounds for concealment, and white phosphorus rounds for multiple applications. White phosphorus had been employed by American forces since the early stages of the Pacific Campaign, primarily for marking targets and creating smoke screens. The chemical burned intensely when exposed to oxygen, producing dense white smoke that could obscure American movements or mark objectives for supporting fires.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story.
Phosphorus rounds were used to mark targets for artillery or naval gunfire, while infantry units employed smoke rounds to mask their advance across open terrain. The standard tactical employment of white phosphorus involved single rounds or small concentrations designed to produce immediate visual effects. A single 81mm white phosphorus round could generate smoke coverage over an area approximately 50 meters in diameter, lasting for several minutes depending on wind conditions. The smoke provided concealment but had limited direct tactical effect, beyond denying observation to enemy forces. What Staff Sergeant Mackenzie and his Marines had developed through experimentation and combat experience represented a fundamental departure from established white phosphorus employment. Instead of using individual rounds for marking or concealment, they had discovered the concentrated applications of white phosphorus could produce effects that extended far beyond simple smoke generation. The breakthrough had occurred during operations on Tinian 6 weeks earlier. Mackenzie's section had been tasked with suppressing a Japanese strongpoint that had resisted repeated infantry assault. Conventional high-explosive rounds had proven ineffective against the reinforced position, while attempts to advance under covering fire had resulted in heavy casualties. In frustration, Mackenzie had ordered his mortars to fire their remaining white phosphorus rounds at the position, hoping that smoke might enable a flanking movement. The results had exceeded all expectations. The concentrated white phosphorus had not merely created smoke, it had effectively neutralized the position through chemical and psychological effects that no American tactical manual had described. Japanese defenders, accustomed to enduring high-explosive bombardments in their fortified positions, found themselves unable to function when surrounded by burning chemical compounds that penetrated into spaces that conventional weapons could not reach. The discovery led to systematic experimentation with white phosphorus employment under combat conditions.
Mackenzie's Marines tested various concentration patterns, timing sequences, and mixture ratios with high explosive rounds. They documented wind effects, target characteristics, and defensive responses through careful observation and prisoner interrogation. The resulting tactical innovations remained largely informal, passed between units through personal communication rather than official doctrine. By December 1944, Mackenzie's section had refined their white phosphorus tactics to a level of precision that would have impressed pre-war artillery specialists. They could calculate wind drift effects, estimate burn duration for specific target types, and coordinate multiple rounds to achieve sustained chemical effects over extended areas. Most importantly, they had learned to exploit the psychological impact of white phosphorus in ways that conventional weapons could not achieve. The Japanese positions on Mount Tapochau represented an ideal testing ground for these refined tactics. The cave system, while providing excellent protection against conventional bombardment, created environmental conditions that amplified the effectiveness of white phosphorus rounds. Enclosed spaces concentrated chemical effects, while the limited ventilation that made cave occupation possible also trapped burning compounds that would dissipate quickly in open terrain. Captain Yamamoto's defensive positions, carefully designed to withstand American artillery and aerial bombardment, had not been engineered to cope with weapons that could penetrate enclosed spaces and continue burning for extended periods. Japanese military doctrine, focused on European-style warfare and conventional siege tactics, had not anticipated the development of specialized chemical delivery systems designed specifically for cave warfare. The interconnected tunnel system that provided tactical flexibility and protected communication also created vulnerabilities that white phosphorus could exploit. Tunnels that carried fresh air to fighting positions could also carry burning chemical compounds. Ventilation shafts designed to remove gun smoke could draw in phosphorus particles that would continue burning in locations far from the original impact points. The defensive advantages of cave warfare could be transformed into tactical liabilities when faced with weapons specifically designed to exploit enclosed environments. American intelligence had provided detailed information about Japanese defensive preparations through aerial reconnaissance, prisoner interrogation, and signals intercepts. Marine commanders understood the layout of major defensive positions, the approximate strength of Japanese forces, and the general characteristics of the cave system. This intelligence enabled precise planning of white phosphorus applications that could achieve maximum effect against specific target characteristics. Staff Sergeant Mackenzie had spent 3 days studying aerial photographs and constructing detailed firing plans that would deliver concentrated white phosphorus effects against each major Japanese position. His calculations incorporated wind speed and direction, target elevation, estimated ventilation patterns, and coordination with supporting arms. The planning process resembled the systematic preparation that characterized American military operations throughout the Pacific Campaign. The tactical innovation represented by concentrated white phosphorus employment extended beyond simple weapon effectiveness. Mackenzie's Marines had developed new methods of observation and adjustment that enabled sustained chemical effects over time periods measured in hours rather than minutes. Forward observers trained to spot the subtle signs of phosphorus penetration into cave systems could direct continued applications that maintained tactical pressure without requiring infantry assault. The psychological dimension of white phosphorus tactics proved equally important as the immediate tactical effects. Japanese soldiers, conditioned to endure conventional bombardment through discipline and fortification, discovered that burning chemical compounds created fear responses that traditional military training could not overcome. The combination of physical discomfort, restricted visibility, and knowledge that chemical weapons were being employed produced psychological effects that exceeded the actual casualty-producing capability of the weapons themselves. December 18, 1944 marked the first systematic employment of white phosphorus tactics against prepared Japanese positions. The 3 weeks of routine harassing fire had been carefully designed to establish patterns of American mortar employment that would mask the preparation for chemical assault. Japanese defenders, accustomed to predictable schedules of American fire missions, would be unprepared for the sustained chemical bombardment that Mackenzie's section was about to deliver. At 12:48 a.m., Staff Sergeant Mackenzie's voice crackled across the radio network connecting his mortar positions. The firing commands had been calculated with mathematical precision, incorporating lessons learned from 6 weeks of Pacific combat and refined through systematic experimentation under actual combat conditions. 8 81mm mortars, positioned at carefully surveyed firing points, prepared to deliver the most concentrated application of white phosphorus that American forces had yet attempted against fortified positions. The rounds loaded in Mackenzie's mortars represented months of tactical development and logistical preparation. Each white phosphorus shell had been individually inspected and weighed to ensure consistent performance. Propelling charges had been selected to achieve identical flight characteristics across all firing positions. Wind speed and direction had been measured using portable meteorological equipment originally developed for artillery operations in Europe but adapted for the specific conditions of Pacific Island warfare. What the Japanese defenders in their carefully prepared positions could not anticipate was the systematic application of industrial-level organization to specialized chemical warfare. The same methodical approach that characterized American military operations across the Pacific would be applied to weapons employment that existed outside conventional military doctrine. The results would challenge every assumption about defensive warfare and introduce Japanese forces to tactical innovations that no military academy had taught and no field manual had described. The thunder that was about to fall on Mount Tapochau would announce the arrival of American tactical innovation applied to the specific requirements of Pacific cave warfare. Japanese soldiers, products of military training that emphasized endurance and discipline in the face of conventional weapons, were about to encounter chemical warfare delivered with industrial precision and sustained over time periods that would test the limits of human endurance in enclosed defensive positions. At 12:48 hours and 30 seconds, Mackenzie gave the command that would transform Japanese understanding of American tactical capability. 8 mortars fired in carefully coordinated sequence, their rounds arcing through the Pacific afternoon toward targets that had resisted American assault for 3 weeks. The shells carried not high explosive designed to breach fortifications, but burning chemical compounds that would penetrate spaces where conventional weapons could not reach and continue their destructive effects long after the initial impact. The first round impacted directly at the entrance to Position Alpha, Captain Yamamoto's primary command bunker. Instead of the familiar crack of high-explosive detonation, a different sound echoed across the ridge. A softer burst, followed immediately by the distinctive hiss of white phosphorus igniting in contact with air. Dense, white smoke began pouring from the cave entrance, but this was only the beginning of effects that would continue for hours and challenge every aspect of Japanese defensive tactics. Within seconds, additional rounds began impacting across the defensive perimeter. Position Bravo, a reinforced machine gun emplacement carved into solid rock, received 3 rounds in rapid succession. Position Charlie, the main observation post that controlled defensive fires across the ravine, disappeared behind a wall of burning white smoke. Position Delta, Echo, Foxtrot, and Gulf followed in sequence, each receiving precisely calculated applications of white phosphorus delivered with timing and accuracy that reflected months of tactical refinement. The systematic nature of the bombardment immediately distinguished it from routine harassing fire. This was not random application of available ammunition, but carefully planned employment of specialized weapons against specific targets. Japanese soldiers, trained to recognize and respond to conventional American tactics, found themselves facing something entirely outside their experience and their tactical doctrine. Captain Yamamoto, crouched in his command position as white phosphorus smoke began filtering through ventilation shafts, realized that American tactical innovation had again exceeded Japanese expectations. The burning compounds that were beginning to penetrate his supposedly secure position represented more than new weapons. They embodied the American ability to identify tactical problems and develop systematic solutions that traditional military thinking had not anticipated. The white smoke pouring from cave entrances across Mount Tapochau announced the beginning of a new phase in Pacific warfare, where American industrial and organizational capabilities would be applied to weapons employment that challenged fundamental assumptions about defensive operations. The thunder of impact was just beginning, and its echoes would reshape Japanese understanding of American tactical capabilities and the changing nature of warfare in the Pacific theater.
Through Captain Yamamoto's command bunker represented the culmination of tactical development that had begun months earlier in Marine training facilities across the Pacific. What Japanese defenders were experiencing was not merely new weapons, but the systematic application of American industrial methodology to specialized warfare problems that conventional military doctrine had never addressed. The white phosphorus that now filled defensive positions across Mount Tapochau embodied innovations that extended far beyond simple ammunition selection. Staff Sergeant Mackenzie's Marines had developed integrated systems for sustained chemical application that combined meteorological analysis, ballistic computation, target assessment, and logistical coordination in ways that transformed mortar employment from supporting fire into primary assault weapons. Understanding the revolutionary nature of concentrated white phosphorus employment requires examining the evolution of American Pacific tactics from the early disasters of 1942 through the systematic innovations that characterized operations by late 1944. Traditional mortar doctrine, developed for European warfare against conventional fortifications, proved inadequate for the unique challenges of Pacific cave warfare, where Japanese engineers had created defensive systems specifically designed to neutralize American tactical advantages. The caves that honeycombed Pacific Islands represented engineering achievements that challenged every assumption about siege warfare. Japanese construction teams, often including civilian mining specialists and naval engineers, had created underground complexes that provided protection equivalent to heavily armored fortifications while maintaining the tactical flexibility of field positions. Ventilation systems enabled sustained occupation, multiple entrances prevented isolation, and interconnecting tunnels allowed concentration or dispersal of defensive fires as tactical situations required. American forces initially approached cave warfare using conventional siege tactics adapted from European experience. Artillery preparatory fires, followed by infantry assault, supported by engineers with demolition charges and flame weapons. The results demonstrated the inadequacy of traditional approaches against defensive systems specifically engineered to exploit the limitations of conventional weapons. High explosive shells that devastated surface positions had minimal effect against targets protected by meters of solid rock. Flame weapons could clear individual caves, but could not penetrate the deep galleries where Japanese forces maintained their command facilities and supply storage. The breakthrough that led to systematic white phosphorus employment emerged from careful analysis of weapon effects under specific environmental conditions. Marine Corps training facilities had constructed cave mock-ups that enabled experimentation with various ammunition types against defensive positions that replicated Japanese engineering techniques. The testing revealed that white phosphorus possessed unique characteristics that could exploit vulnerabilities in cave systems that conventional weapons could not address. White phosphorus burns at temperatures exceeding 1,500 degrees Fahrenheit when exposed to oxygen, producing dense smoke and continuing combustion until the chemical compound is completely consumed.
Unlike high explosive weapons that deliver their effects instantaneously, white phosphorus creates sustained effects that continue for extended periods after initial deployment. More significantly for cave warfare, the burning compounds produce gases and particles that can penetrate spaces inaccessible to conventional weapons and continue burning in enclosed environments where oxygen concentrations would extinguish normal combustion. The tactical implications of sustained burning effects in enclosed spaces had not been systematically explored by any military force prior to American experimentation in Pacific cave warfare. Designed to provide protection through thick overhead cover and limited entrances, created environmental conditions that concentrated white phosphorus effects rather than dispersing them. Ventilation systems intended to make cave occupation possible became distribution networks for burning chemical compounds that could reach defensive positions far from original impact points. Marine Corps testing had revealed that single white phosphorus rounds produced limited tactical effects when employed against cave positions using conventional fire missions. The standard practice of firing individual rounds at specific targets resulted in localized effects that Japanese defenders could endure through temporary evacuation or improved ventilation. However, concentrated applications involving multiple rounds delivered in coordinated patterns produced cumulative effects that exceeded the sum of individual weapon impacts. Sergeant Mackenzie had participated in the experimental program that developed concentrated white phosphorus tactics during training operations at Camp Pendleton in early 1944. The testing involved systematic variation of round quantities, timing intervals, target patterns, and environmental conditions to determine optimal employment methods for specific tactical situations. The results demonstrated that white phosphorus could be employed as a primary assault weapon rather than simply supporting fires when properly concentrated and sustained over appropriate time periods. The key innovation involved treating white phosphorus employment as a systematic process rather than individual weapons effects. Instead of firing single rounds at specific targets, Mackenzie's Marines learned to calculate sustained chemical applications that would maintain tactical effects over extended periods. This required developing new methods for meteorological analysis, ballistic computation, and target assessment that extended far beyond conventional mortar tactics. Meteorological considerations proved crucial for effective white phosphorus employment against cave positions. Wind speed and direction affected not only the trajectory of individual rounds, but also the distribution of burning compounds after impact. Atmospheric pressure influenced combustion rates and smoke dispersion patterns. Temperature variations affected chemical burn duration and the efficiency of ventilation systems in dispersing gaseous byproducts. Mackenzie's Marines had developed portable weather monitoring equipment that enabled real-time atmospheric analysis at the firing position level. Estimates of personnel capacity for various cave types. The logistical requirements for sustained white phosphorus operations demanded supply systems that conventional mortar units had never required. White phosphorus rounds cost significantly more than high explosive ammunition and required specialized storage and handling procedures. The rounds were manufactured in limited quantities compared to standard ammunition types, requiring careful allocation and advanced planning for extended operations. Transportation to forward positions involved additional safety considerations due to the hazardous nature of white phosphorus compounds. Marine Corps supply units had developed specialized procedures for white phosphorus logistics that ensured adequate ammunition availability while maintaining safety standards appropriate for chemical weapons. Forward supply points maintained segregated storage areas with fire suppression systems designed for chemical incidents. Transportation units employed specially trained personnel and modified vehicles equipped for hazardous materials handling. Medical facilities prepared antidotes and treatment protocols for white phosphorus exposure incidents. The organizational innovation required for systematic white phosphorus employment extended throughout Marine Corps tactical units participating in Pacific operations. Forward observers required training in chemical weapons effects and specialized observation techniques for adjusting white phosphorus fire missions. Communications personnel needed familiarity with procedures for coordinating sustained chemical applications across multiple firing units. Medical personnel required preparation for treating casualties from chemical weapons employment by friendly forces. Training programs developed at Marine Corps schools prepared personnel for white phosphorus operations through systematic instruction that covered technical, tactical, and safety aspects of chemical weapons employment. Students learned to calculate ammunition requirements for sustained chemical applications, coordinate multiple firing units for concentrated effects, and adjust fire missions based on observed chemical weapon performance under various environmental conditions. The Marine Corps had transformed white phosphorus from a specialized marking round to a primary assault weapon through systematic application of American industrial and educational methods to tactical problems. The same organizational approaches that enabled American industry to mass-produce complex weapon systems were applied to mass-producing trained personnel capable of employing those weapons with maximum effectiveness against specific enemy defensive systems. What Captain Yamamoto and his Japanese defenders were experiencing on Mount Tapochau represented the culmination of this systematic development program. The white phosphorus that continued burning in cave systems across the defensive perimeter embodied months of tactical refinement, technical innovation, and organizational development that had transformed American capabilities for cave warfare. The sustained chemical applications that Mackenzie's Marines were delivering represented tactical effects that no Japanese military doctrine had anticipated or prepared to counter. Japanese defensive planning, based on successful resistance to conventional American assault techniques, had not incorporated countermeasures against weapons that could penetrate enclosed positions and continue burning for extended periods after initial employment. The psychological impact of sustained white phosphorus applications proved as significant as the immediate tactical effects. Japanese soldiers, trained to endure conventional bombardment through discipline and proper use of protective positions, discovered that chemical weapons created entirely different psychological stresses that traditional military conditioning could not address. The knowledge that burning compounds were penetrating supposedly secure
positions challenged fundamental assumptions about defensive warfare that formed the basis of Japanese tactical doctrine. Japanese medical personnel documenting the effects of concentrated white phosphorus applications reported symptoms and casualty patterns that differed significantly from conventional weapons effects. Burns from white phosphorus compounds continued developing after initial exposure, requiring treatment techniques that field medical units were not equipped to provide. Smoke inhalation in enclosed spaces produced respiratory injuries that persisted long after exposure ended. More significantly, the psychological trauma associated with chemical weapons employment appeared to affect even uninjured personnel in ways that conventional combat stress did not produce. Captain Yamamoto's situation reports to higher headquarters described tactical effects that Japanese commanders found difficult to accept or understand. Defensive positions that had successfully resisted weeks of American assault were being neutralized by weapons that produced no visible damage to fortifications or equipment. Personnel casualties from direct chemical exposure remained relatively light, but the tactical effectiveness of defensive units deteriorated rapidly as sustained white phosphorus applications continued. The interconnected tunnel systems that provided tactical advantages under conventional bombardment became transmission networks for chemical compounds that affected positions throughout the defensive complex. Soldiers occupying positions distant from impact points reported difficulties breathing, reduced visibility, and psychological stress from knowledge that chemical weapons were being employed. Command and control systems designed for conventional warfare proved inadequate for coordinating defensive responses to chemical attacks that continued for hours rather than minutes. Japanese attempts to counter American white phosphorus employment revealed the systematic disadvantages that Imperial forces faced in tactical innovation during the final stages of the Pacific War. Japanese units possessed technical knowledge of white phosphorus compounds and understood the basic principles of chemical weapons effects. However, they lacked the industrial infrastructure, trained personnel, and organizational systems that enabled American forces to develop and deploy specialized tactical innovations under combat conditions. Japanese mortar units attempting to replicate American white phosphorus techniques discovered that successful employment required more than simply firing available chemical rounds at American positions. Effective chemical warfare demanded meteorological equipment that Japanese units did not possess.
ballistic computation capabilities that exceeded Japanese mathematical training and ammunition quantities that Japanese logistics could not provide. Most critically, Japanese units lacked the systematic training and organizational support that enabled American Marines to employ white phosphorus as a primary assault weapon rather than simply supporting fires. The Battle of Mount Tapochau demonstrated that American tactical innovation had achieved superiority in specialized warfare techniques that extended beyond simple equipment advantages. Japanese forces, despite maintaining numerical parity and occupying defensive positions that favored defenders, found themselves systematically degraded by American weapons employment that their military doctrine had not anticipated and their organizational systems could not effectively counter. The sustained white phosphorus applications that continued throughout December 18th represented tactical effects that accumulated over time rather than achieving immediate decisive results. Unlike conventional bombardments that either succeeded or failed based on immediate destruction of target systems, chemical weapons employment created progressive degradation of defensive capabilities that eventually resulted in tactical failure even when individual weapon impacts
produced limited immediate effects. By 1400 hours, Japanese defensive positions across Mount Tapochau were experiencing tactical effects that exceeded anything in their combat experience. White phosphorus compounds continued burning in cave systems despite Japanese efforts to improve ventilation or temporarily evacuate affected positions. The sustained chemical applications made normal defensive activities impossible, while American forces maintained the capability to deliver additional rounds whenever Japanese personnel attempted to resume defensive operations. Captain Yamamoto's attempts to coordinate defensive responses revealed the fundamental challenges that sustained chemical applications created for conventional military operations. Personnel rotation to limit chemical exposure disrupted unit cohesion and degraded tactical proficiency. Communication systems designed for conventional operations could not effectively coordinate defensive measures against weapons that produced sustained rather than instantaneous effects. Supply systems intended to support conventional combat operations could not provide equipment or materials necessary for chemical weapons defense. The tactical innovations that Mackenzie's Marines had developed for white phosphorus employment represented broader changes in American military capabilities that characterized Pacific operations by late 1944. The systematic approach to weapon system development, the integration of technical and tactical training, and the organizational support for specialized operations embodied military methodologies that combined American industrial capabilities with combat experience gained through systematic analysis of tactical problems under actual combat conditions. American forces had transformed military operations from traditional approaches based on courage, discipline, and tactical skill into systematic applications of technological and organizational superiority that could overwhelm conventional military virtues through sustained application of specialized weapons and tactics. The Japanese experience on Mount Tapochau provided crucial insights into the changing nature of warfare during the industrial age. Traditional military qualities, including unit cohesion, individual courage, and tactical proficiency, remained important, but they were becoming secondary to systematic application of technological and organizational advantages that could neutralize conventional military capabilities through sustained application of specialized weapons and tactics. The Japanese staff officers analyzing American white phosphorus employment recognized that they were witnessing tactical innovations that represented fundamental changes in military capabilities rather than simple improvements in existing weapon systems. The Americans had developed integrated approaches to specialized warfare that combined technical innovation, systematic training, organizational support, and industrial logistics in ways that traditional military thinking had not anticipated. The psychological impact of sustained chemical applications extended beyond immediate tactical effects to influence Japanese strategic planning and defensive doctrine throughout the remaining Pacific campaigns. Units that had successfully employed cave warfare techniques against conventional American tactics found themselves unprepared for weapons that could penetrate enclosed positions and continue producing tactical effects over extended periods.
Japanese defensive planning for subsequent operations incorporated lessons learned from Mount Tapochau, but the organizational and industrial capabilities required to counter American white phosphorus tactics exceeded Japanese resources during the final phases of the Pacific War.
Knowledge existed within Japanese military organizations, but the systematic application of that knowledge to develop effective countermeasures required industrial and educational infrastructure that Japan could not provide under wartime conditions. The white phosphorus employment techniques developed by Mackenzie's Marines influenced American tactical doctrine throughout the remainder of the Pacific Campaign and into the post-war period. The systematic approach to chemical weapons employment became standard procedure for Marine Corps units conducting cave warfare operations, while the organizational methods developed for specialized weapons training were applied to other tactical innovations that emerged from combat experience. Military analysts studying American white phosphorus tactics recognized that the innovations represented broader principles of military effectiveness that extended beyond specific weapon systems or tactical techniques. The ability to identify tactical problems, develop systematic solutions, train personnel for specialized employment, and provide organizational support for sustained operations embodied military capabilities that could be applied to various technological and tactical challenges. The Battle of Mount Tapochau marked a pivotal moment in Pacific warfare, where American tactical innovation demonstrated superiority over conventional military approaches through systematic application of specialized capabilities developed specifically for unique combat environments. Japanese forces, despite maintaining defensive positions designed to neutralize American tactical advantages, found themselves systematically degraded by weapons employment that their military experience had not prepared them to counter effectively. The sustained white phosphorus applications that neutralized Japanese defensive positions represented more than tactical success in a single engagement. They embodied the emergence of military methodologies that transformed warfare from traditional contests between opposing military forces into systematic applications of industrial and organizational capabilities designed to achieve decisive tactical effects through sustained employment of specialized weapons and techniques. The echoes of burning white phosphorus across Mount Tapochau announced the arrival of military capabilities that would characterize modern warfare, where technological and organizational superiority would prove more decisive than traditional military virtues. Japanese soldiers who experienced sustained chemical applications were witnessing the birth of warfare methodologies that would dominate military operations throughout the industrial age and beyond. American white phosphorus tactics shattered Japanese conceptual frameworks for defensive warfare and demonstrated the inadequacy of conventional military approaches against systematic application of specialized capabilities developed through industrial methods and applied with mathematical precision to specific tactical problems. The burning compounds that penetrated Japanese cave systems represented not just chemical weapons, but the manifestation of military-industrial systems that transformed traditional warfare into systematic processes designed to achieve decisive results through sustained application of technological and organizational advantages.
Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.